We're going to be working on logarithmic equations, solving equations today. So we're happy to have you here today. Thank you for coming to my YouTube channel. If you can, please subscribe, do a like, write a comment below, and then we're going to get going. It helps me out a lot. You know what I mean, you guys? So if you can do that, that'd be great. All right. My name is Sensei, and we are doing Math 3 Honors. Hey, Nathaniel, was that a good start?
Yeah.
So when you get on the YouTube, do you think I could get monetized with that, Nathaniel? I'm trying to get monetized.
Yeah, for sure.
Yeah. You know, I think I could do it if enough people start watching my videos. Abraham, guess how many people watch my videos when I check them out?
Maybe like a few million.
Close. Like 4. 4 people.
Pretty close.
4. Do you think if I make like, how much you make per person clicking on? Like, how much? Like $10? I probably make $40. Buy a couple burritos with that. I don't know. Brett, did you subscribe to my channel?
Not yet.
What? I thought you said not yet. Of course you've subscribed. Make sure you like the video. Alonzo, we miss you. Okay, should we all say hi to Alonzo? You know what I mean. Poor Alonzo. All right. Okay, let's get to work. Can I wait, what am I doing here? Ethan, what's up with your camera, man?
Remember when I said my Chromebook runs really slow and I think it was the camera? I still need to get my Chromebook replaced.
Is it working fast for you now that your camera's not on?
Yeah, just a little bit faster.
All right. Okay. Hey, Thomas.
Yeah.
I know I was talking to you before. I have a confession to make. Today's not Friday. It's really Monday.
You lied to me?
I did. I have to be real. I'm not going to lie anymore because I was lying. Samantha, did you know that it's really Monday today?
No.
It is. I'm sorry. Did that mess you up? Am I messing you up, Samantha? Samantha, I apologize. Oh my gosh. Melissa, did I mess you up? I'm sorry, Melissa.
Yeah, but it's okay. I think I can.
Oh my gosh, you're so forgiving. Okay, you guys, here we go. Here's a lesson. Let's get started. It's Monday. We have 4 more days of this awesomeness doing math. You know what I mean? Doing math together is amazing. 4 more days of it. I mean, I just don't want to stop. I think we should go on Saturday. Let's just hang out on Saturday, do math together. Let's all click on here. You know, we're supposed to be starting. This we're doing 5.4, page 279, 3 through 39. It's every other odd, not odd, every other odd. Expanding logarithms. Oh, wait, that's not it. No, that's yesterday's. Wait, what the heck? Where's today's? Oh, here it is. Sorry. 5.5 today. 3 through 49, every other odd. It's every other odd today, 3 through 49, solving exponential and log equations. Maybe we should do this on Saturday. We're supposed to start school tomorrow, but they decided not to. I'm not sure when it's going to start. Does anyone know? We'll find out. Three through 49 odd, solving exponential and log equations. Okay, you got that written down? Okay, I'm going to read this in 10 seconds. 5, 4, 3, 2, 1. Okay, where are you guys? Okay, so let's get started on the homework. You guys can start bringing that up. I got a poll. I got a curious poll for you. I like doing polls. All right. Check out the poll I just sent. There it is. I'm going to check that in later. You guys can answer that quickly. Cassandra, what I would suggest for you to do, oh, Cassandra can't hear me. Cassandra, I am talking. Can you hear me? I don't know. Does that close my poll? Oh, did I lose my poll? Oh, it's still going live. Okay. Okay, let's see here. Cassandra, I can see you. Can you hear me? Okay. Hope you got my message, Cassandra. Okay, so let's take a look at number. We're going to skip 3 and do 7. You guys don't worry about 3. I wanted to show you something here. Let's see. Look at we have here, if you look on 5.5, oh, well, let's talk about what we're doing for the week, okay? What we're doing for the week. So you guys know what's going on. 286, 3 through 49, every other odd is today. And then we're going to start doing a new lesson, conic sections, on Tuesday and Wednesday. So we're going past chapter 5, but then we're going to review the test on chapter 5 so that we take the chapter 5 test on Friday. So we're not going to do conic sections test on Friday. We're just going to do the chapter 5 test on Friday. And just, assignment 5. Oh, man. Assignment 5.5 and 5.4 is due also. So I need to put that here. 5.4 due. So we're going to have a test on Friday and we're going to start a new lesson tomorrow. Okay. So hopefully that works. Another thing. Sorry, that's my phone. Another thing what I'd like for you guys to see here is if you look here on 5.5, you have the self-practice. But look here, 5.5 worked out solutions. That not only, I mean, you have the answer key, but this one has the worked out solution. So not only does it have the the answers, but it shows you how to do the problems. So you have to search around for it. But look here, it shows you the step-by-step stuff. It helps out a lot, those of you who are like getting this. So look at this. This is the worked out solutions. And it goes all the way up here to the top, but you want to skip, you go past the exploration, as answer the exploration, monitoring progress. But right here is where we do the assignment, the exercises, right? The exercises. Okay. So we're going to skip 3. And let's go with number 7. We're doing number 7. You guys don't have to do 3. We're doing number 7, starting 7. Let's go ahead and solve. It's basically solving equations with the logarithms. Whoa. Looking for 7. Okay, so here we go. Number 7. Number 7, boss. Okay, 7 is 5x minus 3 equals 25x minus 5. Okay, I think I am presenting now, right? Okay, so how do we solve this problem with the exponents in here? We could use logarithms, but we don't really need to right now, the way this is set up. And so before we solve this problem here, as you guys are writing this down, I got a question. Let's do another one over here. If I say 2 to the x equals 2 to the 5th, what does x equal in order for that equation to be true? Or what does x equal there? Let's go with, did Cassandra come back? Cassandra, did you come back? All right. Let's go with Elise. Let's go with Angel Lopez. What does x equal there, do you think? In the orange, Angel?
5.
Yeah. Why?
Because 2 times 2 times 2 times 2 times 2 is equal to 2 to the power of 5.
Yeah. If this is 2 and this is 2, in order for them to equal, this must also equal 5, right? If this is 5, if this is 2, then this must also be 5 if this is 5. So as long as the bases are the same, these must be equal. Now let's go here. This one, the bases are not the same. But can I use an exponent like this is 5 to the x minus 3 equals, how can I make 5 to the what is going to equal 25? What should I put over there to make that equal to, let's go with Brett. What should I put up here for this 5 to make it equal to 25? Like, how do I make this 5 equal 25? What exponent should I put up there?
2.
Yes, and now we have a common base. 5 to the x minus 3, and instead of 25, we put 5 squared. Now, I also must put my x minus 5 back here. And do you remember our exponential rule? When I'm raising, it's the power rule, I raise it up. I multiply this times this, right? If I said here 7 third raised to the 5th, that would equal 7 to the 15th, right? So the same thing is here. I just multiply that times that. So I'm going to say 5x minus 3 equals 5. 2 times x is 2x. 2 times 5 is negative 10. Now, look at here. We have bases the same. So, what can I say? Like I said, x equals 5. What can I say about x minus 3 and 2x minus 10? How can I solve this equation, Carlos? What do you think?
Plug in a number for x.
Plug them in?
Mm-hmm.
No, like what do you mean by that? Just plug in random numbers and see if they work?
No. Add 3? I'm not sure.
Okay, you're on the right track, sort of. Hang in there, Carlos. Connor, what do you think?
You say he was on the right track, so maybe like add 3 to both
well, look
sides.
Here, Connor,
look
here. Connor, look here. So we said 2 equals 2, and then we finally said, hey, this must equal that. So we said x equals 5. Can you do the same thing here is what I'm trying to say. If that doesn't help you, I'll ask someone else. It's okay. I've never taught this to you. All right. Hang on. Emma, can you help him out?
I'm not sure.
Okay. Connor, Emma, Carlos, and everyone else, look here. Just like these are the same base, I say x equals 5, right? So these are the same base, so I can say this. Watch this. This must equal that. Just like x must equal 5, x minus 3 must equal 2x minus 10. Boom. There's our equation. And then we just go ahead and solve. We just get the same base, and then we just set them equal, and then we solve it. Connor, did that help? Or no?
Yeah, it did. It did.
How about you, Carlos?
Yeah.
How about you, Emma?
Yeah.
All right. So anyway, negative 1x equals negative 7. Divide by negative 1. And we get x equals 7. Boom, 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 shakalaka, boom. Okay. I'll leave that there. You guys can go ahead and copy that down. Hopefully I can scoot up. Like I can go. That's the whole thing, but I'm just going to put this bottom part here because I kind of stopped. You guys can go ahead and copy that. Are there any questions? Okay, I'm going to get rid of this in 10 seconds. 5, 4, 3, 2, 1. Okay, let's go with, what's my next question? 7, 9, 11. 11 I'll set up for you, but I'm not going to do for you. So the idea is I want the same base. And this, I can make a base of 10. I can make this a base of 10 also. So 100, 5x plus 2 equals 1 over 10 raised to the 11 minus x power. Okay, so same thing. I can make these a base of 10. So 100 will be 10 squared raised to the 5x plus 2 power. And 1/10, how can I write that as a base of 10? 1/10. What do you think, Julissa? How can I write 1/10 as a base of 10?
10 to the negative 1?
Nice. Whoa, strong. That was a strong answer. Very good, Julissa. 10 to the negative 1. And now I see I have the same thing, so I just multiply that times that times that. So it'll be 10 to the 10x plus 4 power equals 10 to the negative 11 plus x. And then you just set, now that I have the common base, you just set the exponents to each other. 10x plus 4 equals negative 11 plus x. Okay, I'll let you guys solve that on your own. I'm going to get rid of this in 10 seconds. Are there any questions? Leave space to solve it, or solve it as you go. So 11, 13, 15's next. I'm going to get rid of this in 10, 9, 5, 4, 3, 2, 1. Okay, so we're at 15 next. Okay, so now look at this. Look at this crazy thing here. We have this as a base of e. Now, remember we did the base rule? Well, anyway, let me write it down. 15 is 3e to the 4th plus 9 equals 15. Okay. Oops. 3e to the 4x. Sorry, I forgot that x there. 3e to the 4x. Okay. So now 3e to the 4x plus 9 equals 15. Now we're solving for x. Remember, e is just a number, like pi is 3.14. Oh, by the way, happy Pi Day yesterday. Yesterday was Pi Day. E is a number 2.718, something like that. It goes on forever. Now we're solving for x, but let's get e by itself. Subtract 9. 3e raised to the 4x power equals 15 minus 9 is 6. Now to get e by itself, I divide by 3. And I'm left with, let's do this over here, e raised to the 4x equals 6. Now, we have a logarithm with a base of e. So what we do is we just rewrite this. We multiply both sides by the natural log. Okay? Now this is log. What's that?
It's supposed to be a 2, not a 6.
Oh, sorry. Thank you. That would make life a heck of a lot worse. So let me rewrite it. E to the 4x equals 2. We multiply by the natural log on both sides. Okay, natural log. What that does is that because this is a base of e and this is a base of e, it's actually going to make this equal to 4x. Not an exponent, but those cancel out, and it's now 4x equals the natural log of 2. We talked about that as the change of base. If you guys remember that from yesterday, and I can show it to you if you want, but just know we add the natural log, and now this is not x, this is like a base, it's a whole number, and we just find the natural log and divide by 4. So x equals the natural log of 2 divided by 4, and we use our calculator to solve that now. So let me get my trusty dusty calculator. So you find the natural log of 2, and then we divide that by 4, and we get, let me, natural log of 2, divide by 4.17. Here's my answer. X equals 0.173. Are there any questions on that? Okay, so 17, 19 is next. Word problems. Okay, so this is based on this. Okay, let's read this. You are driving on a hot day when your car overheats and stops running. The car overheats at 280 degrees Fahrenheit and can be driven again at 230 degrees Fahrenheit. When it is 80 degrees Fahrenheit outside, the cooling rate of the car is 0.0058. How long do you have to wait until you can continue to drive? Okay, so let's look at Newton's law of cooling. This guy was a genius how he figured this out. There it is. Okay, here it is right here. It's this right here. So write this down. I'm going to write it down too so you guys can see it. T equals T0 minus TRE raised to the negative RT plus TR. Now, TR, let's write down what these letters mean here. T is like the temperature we want. That's the way I'd best describe. That's what we want it to get to. So that's the temperature we want. T0 is what the temperature is, right? Remember, it's too hot, it overheated. That's the overheat temperature. Overheat temperature. And then the TR, that's like the room temperature or the atmosphere temperature. It's the outside temperature. And then the little r is the rate of the temperature. Okay, so those are the numbers we want. T is the temperature we want. That's T0 is where it's overheated. TR is the outside temp and R is the rate. So looking here at our problem again, I'll get back to that on my what I've written down first, but let's write down what we got. I'll give you guys one final look. Okay, so we want to drive it at 230 degrees again. So that's the T. That's 230 degrees. And then T0 is the T0 is where we overheated. So it overheated at 280 degrees. So that's the T0. And I'll show you guys this in just a second. That's 280 degrees. The outside temperature is 80 degrees. That's the TR. And the rate of cooling is 0.0058. Okay, so here I have everything listed here. So go ahead and write that out. T is the 230. T0 is when overheated at 280 degrees. TR is the outside temp at 80 degrees, and R equals the rate at 0.0058. Okay, so let's plug in our numbers. So T is what we want, so that's 230 equals T0 is when it overheats. That's 280 degrees minus TR is the outside temperature. That's 80 degrees. We have E. R is negative 0.0058 T. Now, T is what we're solving for. It's in the exponent. Plus T to the R, again, is 80. All right. So the idea behind this is we need to solve for E. All right. So how do I get e by itself? Remember like the one we did before, how we got e by itself? What do I do to get the e by itself? Let's go with Cassandra. See if she came back. Are you back? Can you hear me now, Cassandra?
Yeah, I can hear you.
All right, cool. Do you remember, you weren't here, but do you know what I do next for this, or should I call in someone else?
I have no idea.
All right. Well, let's flipped it through. All right, Sam. What do I do?
Algebra.
Sure, yeah.
Oh, do you want me to like tell
Well,
you
just
that?
give me the first step. What am I gonna do?
Oh, okay. Subtract 80.
There you go. Subtract 80. Okay, Sam got us at that. 230 minus 80 is 1. No, is it 150? It better be. What the heck? $150. Oh, before we do that though, let's combine these two. 280 minus 80. 150 equals 280 minus 80 is 200 e 0.0058 negative raised to the t. What do I do next? Billy.
Divide.
Yeah, by how much?
200.
There you go. 150 divided by 200 is 0.75 equals e to the negative 0.0058 t. Now, do you remember how we got rid of the e last time on the last problem that we did? We have an e right there. We just did it. See if anyone remembers. Let's see if Naveed remembers. Do you remember, Naveed?
Multiply by the natural log.
Yeah, so natural log. So that's going to make this natural log of 0.75 is going to be equal to, the e is going to cancel out, negative 0.0058 t. Find the natural log of 0.75 and divide it by negative 0.0058. Okay, just find the natural log of that, and then that'll get us our t. So let's go ahead. What a crazy problem. Wait till your test. You know what I'm talking about. You know what I'm talking about. Divide by negative 0.0058. And I got, what? That didn't work. Natural log. See what you guys get. Try to follow along with me what I get here, right? You guys got to be able to calculate this here yourself. Divided by negative 0.0058. 49.6 minutes. $49.6 minutes. All right, are there any questions on that? I'm going to get rid of this in 10 seconds. That's 19. 21. 23, I believe, is next. 23 is a simple pimple. Then they start getting harder. 23. What we're going to do is take the log 2, 3x minus 4 equals log 2 to the 5. Well, all we have to do, essentially what we're going to do is if we give this both a base of 2 and kind of wrote it like 2 raised to the log 2 3x minus 4 equals 2 raises to the log 2 to the 5. What that's going to do is going to cancel out the logs, flink, flink, and make this 3x minus 4 equals 5. And then you just solve it like that. You're kind of raising it to the base. We did that as the power rule yesterday. And then you can solve it. Essentially, what's going on is these log 2's cancel out. That's really what's going on. And you make it 3x minus 4 equals 5. But, so you guys can solve that on your own. I'll give you a second to finish copying what I have. But I'm going to move to 27 next. 27. All right, let's look at 27. Now, this is the same idea here. Log 7, 4x plus 9 equals 2. Now again, okay, we do the same thing. What we're going to do is, because this is a log base 7, what do I want to write my base? Like here, this was a 2. I made my big base 2, big 2. What do I make that base of for that one? What do I make the base for that one? Melissa, what do I do?
Wait, what was it?
What's that, Melissa?
What was the question?
I said, if you have 2 penguins and then they eat a cookie, how many donuts do you have?
7.
No, that's true. You are doing a very good job. Now, can you pay attention to this problem, please?
Yes.
Okay, stay with us, Melissa. I'm calling on you soon, okay? I'm going to call on you. Mara. I'm going to ask again, Mara. Mara.
Yeah, I'm here.
All right. So do you know what I'm asking, or do you need to ask it again?
Can you ask again?
Okay, so see, how do I eliminate this log 7? Notice this was log 2 for this one here. Do you see that?
Yeah.
I raised it to the second power, and that eliminated it, right? So what do I do here?
Put a 7 in front of the log.
Yes, actually, I said raise second power. I said make the base of 2, so that's a base of 7. So now this is a base of 7 there. So now that's 7 squared. See, that's a big, fat 7. Rawr. So now these cancel out. This becomes 4x plus 9 equals 7 squared is 49. So whenever you have something log 7 like that, you just make the base of that number. It's like the common base. Right, Melissa?
Yeah.
Okay, so then you go ahead and solve this using algebra. You guys solve that. 27, 29, 31. Can I fit 31 in here? Can I fit 31 in that? Save some turtles. Wait, are we supposed to do 31? Yeah, okay. So now 31, let's write out log 2. Look, it's a quadratic. X squared minus x. Don't worry about it. We know how to solve quadratics. We're all over that. But again, it's log 2. Log base 2 x squared minus x minus 6. Okay? So how do I get rid of this log 2? See if you guys are getting this now. It's the same idea of the ones we've been doing. I'll pause here for a second so you guys can see what so you guys can catch up. But how do I cancel out that log 2 and make that x squared, get that x squared minus x all on its own? All right? This log base 2. Log base 2. Log base 2. All right. Miley, tell me what to do.
Raise it to the second power.
Or make it a base of 2.
Or yeah.
Yeah, that's what you meant, right? Because those are the words I used, which were wrong. But is this what you meant?
Yeah.
Miley? Okay, cool.
Yeah.
So that makes this boom. And then we have, now it's x squared minus x minus 6 equals 2 squared is 4. Right now it's a quadratic. So how do we solve a quadratic? Melissa, how do we solve a quadratic?
Make it equal to 0.
Oh yeah, that's what I'm talking about. And then you guys can x squared minus x minus 10. So you guys can solve that, either use a quadratic formula or factor. Are there any questions on 31? 35, 31, 33. We're on 35 now, I think, right? Next every other odd. Let me get rid of this in 10 seconds. 3, 2, 1. Okay, 35. Okay, we're almost done here, guys. I'll let you guys finish the rest on your own. But 35, we have the natural log of x plus natural log of x plus 3 equals 4. What is the base of a natural log? Ian, what's the base of a natural log?
E.
Oh my gosh. You make me want to cry with such a strong answer like that. Now remember, we have the product property. If I'm adding these, I can make it a multiplication. We did that yesterday. Look at your notes from yesterday. So I can say x times x plus 3 equals 4, which is the natural log of x squared plus 3 equals 3x equals 4. Keep that in parentheses, right? X times 3x. Now, we do the same thing. Before we had the base of e. So we do a big E, raise that to the e, right? And then this eliminates and becomes x squared plus 3x equals e to the 4th power. Remember, e is just a number. So we can just write it like x squared plus 3x, subtract e to the 4th on both sides, set equal to 0, minus e to the 4th equals 0. Now, what the heck is e to the 4th? Remember, e is like 2.718. Well, just take your calculator. If you look on your calculator, sorry, you can copy that, and then I'll get back to the next step. The next step. What is the step? What is the step? It's so windy outside. Freaking cold in my house. So cold. E to the 4th. If you look here on I'm going to zoom it in. Whoa, my calculator. Ah! Look at your calculator. The natural log here, the shift above it is e to the x. That's such a glare. Little adjust. Okay, so can you see that e to the x? So, Maybe we need more light, but like natural light. If I turn this light on. Oh, that didn't help. Maybe if I open my blinds. It's the storm. The storm in Oxnard. Oxnard storm. That's a little better. Okay, so we have good light now. Storm. So e to the x. So look here. I hit, see how it's above? That means I have to hit my second key. Second e to the x. And remember, you can see it there. It's e to the fourth. So I just put 4. And that gives me my number. 54.6, we'll say. 54.6. 54.6. So just say x squared plus 3x minus 54.6 equals 0. And to solve that, we just use the quadratic formula, right? X equals negative b plus or minus square root b squared minus 4ac all over 2a. And you plug in your a, b, and your c. It's just that the c is equal to negative 54.6. It's just a weird number, but you can do it. You can calculate that out. And I'll let you guys calculate that out. Go ahead and, are there any questions? All right. I am going to get rid of this in 10 seconds. Okay, the rest you guys should be good with. Okay, if you're totally lost, go ahead and check out the solutions, the full step solutions. What's it called? It's the what's it called? It's called the worked out solution. Sorry, that's what it is. It's off the tip of my tongue. The worked out solutions, if you have questions, it'll show you the step-by-step process for those. Tomorrow we're doing conic sections. And are there questions? Okay, if you have no questions, well, actually, what was my poll? What did you guys say my poll was? Do you guys learn? Some of you learn just as well online as you do in the I don't believe it. I don't believe you learn as well online as you do in the classroom. No way. No way. Could I be wrong? I don't know. It just seems like it'd be hard, but hey, you're learning just as much. Should we just do always online learning? All right. You guys, I'll see you later. You can go. Woo! See you later. Bye, Samuel. Bye, Angel. Bye, Ian. Bye, Julissa. Bye, Thomas. Bye, Miley. Bye, Connor. Bye, Emma. Bye, Ethan. Bye, Brett. Bye, Samantha. Bye, Abraham. Bye, Naveed. Bye, Billy. Bye, Linda. Bye, Carlos. Aw, Carlos, I'm sad to see you go. All right. What's up, Angel?
Hi. I just had trouble putting in the equation in the calculator. And number 19, it says like syntax error. So I was just wondering if you could show me how to put it in.
Okay. Hold your calculator up to your camera for me. I want to see what it looks like.
You have the same one.
Oh, then just hit ln
Uh-huh.
natural log 0.75.
0.75.
Close parentheses. Yeah, close parentheses.
Mm-hmm.
Enter. What'd you get?
Negative 0.2876.
Okay, then divide by negative 0.0058.
Negative 0.0058.
After you do that, it should not do that. Hang on. That's weird. Okay. Let's do step by step. So you got the hard part is doing the log, the natural log.
Yeah. And then 0.75.
Okay, so yeah, so let's go again. Let's stop there. Natural log 0.75, right? Can you see mine? Oops.
Yeah, I can see.
Natural log 0.75. Enter. You got that, right?
Yeah, the exact same one.
Then you just hit divide.
Mm-hmm.
It should say answer slash. Does yours say answer slash?
Yes.
Then you hit, wait a minute. For negative, are you hitting this button for negative?
Yeah.
Or this button? You have to hit this button. This is your negative button.
Oh.
Negative
Mm-hmm.
0.0058. If you hit that minus, it throws the calculator off because it's dividing, then subtracting. That's the negative.
Okay, thank you, Sensei.
You're welcome.
It's because I noticed we had the same calculator and it wasn't working for me.
You know what? That makes it easier.
Yeah.
It makes it easier to show you since we have the same calculator, so that's good.
Okay.
All right, dude.
All right.
Okay, have a good one.
You too.